Let's look at example 4. So we have a parabola. It's been rotated that angle. Go through the same thing. So cotangent of 2 theta is A minus C over B. That is not in my unit circle. What am I going to do? Well, you don't just stop. You do not use a calculator to give me a decimal. I want exact values. So we're going to go and we're going to draw a triangle. Because again, I am a visual learner. Now I know 2 theta is in the second quadrant. So I'm going to label that angle as 2 theta. And remember, cotangent is adjacent over opposite. And this part's got to be negative because I'm in the negative x direction. And then using the Pythagorean theorem, or just knowing that that's a 3, 4, 5 triangle. What does that tell you? Well, it tells you that the cosine of 2 theta is negative 3/5, and yes, it tells you the sine of 2 theta is 4/5. And no, you can't just divide by 2 and say, oh, that's the cosine and sine. No, no, no. We have to use those dreaded half-angle formulas that you learned way back in trigonometry. That the cosine of theta is equal to the square root of 1 plus the cosine of 2 theta over 2. We have one for the sine of theta as well. And yes, you should have seen those formulas in a trig class. You might not remember them. That's okay. That's why we are reviewing. So both of these formulas use the cosine of 2 theta. So I'll be using that value in order again to find the exact value of sine and cosine. So here it's just a little bit of arithmetic. So 1 minus 3/5 is 2/5, divided by 2 is 1/5, so I'm going to say that's 1 over the square root of 5. You could rationalize that, or I'm just going to leave it. Here this is going to be 1 minus the minus 3/5, so that's going to be 1 plus 3/5, that's 8/5 divided by 2 is 4/5. The square root of 4 is 2. I'm just going to leave that square root of 5. So those are my exact values for sine and cosine. Now I am ready to write those rotation formulas. Okay, so x is equal to, look at your notes, what comes first? The cosine. So I have 1 over the square root of 5 times x hat minus the sine times y hat. And then my y is equal to the sine plus the cosine. So those are your rotation formulas using exact values, drawing a triangle, and using some half-angle identities from a long time ago. Let's just practice that process one more time with example 5. Right, so we have the cotangent of 2 theta is A minus C over B. Again, 7/24 is not on our unit circle. It's something we need to memorize. So again, I'm going to draw a triangle, and since this is positive, I know that 2 theta is in the first quadrant. Remember, between 0 and 180 degrees. First quadrant's positive, second quadrant's negative for the cotangent. So again, the cotangent is adjacent over opposite. Using the Pythagorean theorem, or knowing your Pythagorean triplets, I know the hypotenuse is 25. So the cosine of 2 theta is 7 over 25, and I only need to know that because of these half-angle formulas. So I'm going to substitute this value in. So let's just do the arithmetic. So we have 1 plus 7/25 divided by 2. So the cosine of theta is the square root of 1 plus 7 over 25 is, I believe, 32 over 25. Divided by 2 is 16 over 25. And the square root there is 4/5. That's kind of nice. All right, let's see what the sign gives us. So that's 1 minus 7 over 25. So that's going to be 18/25. Divided by 2 is 9/25. And so our sign is 3/5. So now we're ready to write our rotation formulas. Remember, we start with cosine, and that's kind of nice to remember, or easy to remember. X goes with cosine. We have to remember that it's minus. And then y goes with sine, and it's plus. And there you have the exact value for the rotation. Now, what is theta? I still don't know what it is. I could punch it into my calculator and say, well, theta is going to be the inverse sine of 3/5, whatever that angle is. And that's an approximation which might help me graph it later, but that's not what I'm looking for right now. I want to know those exact values for those rotation formulas. This is going to definitely test your algebra skills. We're going to eliminate the xy term, and so we're going to rotate the axes so this equation has no xy term. So we're going to go back to example 3 and grab those rotation formulas. And what we're going to do is everywhere there is an x, we're going to substitute that value in. Everywhere there is a y, we're going to substitute that value in. Also goes for there. We're going to do all that algebra, collect like terms, and if we've done it correctly, everything that has an xy multiplied together will go away. So we have to be very careful. It's a lot of foiling. So let's just dive in. So in place of x, I'm going to write this. But you know, since I have all those fractions, how about let's go ahead and factor out that 1/2 and write it like this. Same thing over here. That might be a little bit helpful. Okay, so now I'm going to substitute this in. So if I square the 1/2, I'm going to have 1/4. And let's just go ahead and write this as that quantity squared, plus the square root of 3 times x. So I'm going to have 1/2 times this times y, so that's another 1/2, plus 2 y squared. So again, if I square the 1/2, that's going to be 1/4, quantity squared. And if you don't mind, I'm going to move that 10 to the other side. So let's just equal to 10. Now that doesn't, I know that looks scary. Just hold on. We're going to do some multiplying. Would you agree that 1/2 times 1/2 is also 1/4? If you look, then each term would have a 1/4. So how about this? Let's get rid of those fractions. So let's multiply each side of the equation by 4 to get rid of those fractions. So those go away, so I still have that square root of 3 out in front. That went away, so I still have the 2. And then I need to multiply the 10 times the 4, so I get 40. So at least now I don't have fractions. It's looking a little better. Okay, so now I just need to multiply all this out carefully. That's the key word. Don't go too fast. Carefully. Right? So if you need to, you might want to write that out side by side. X minus the square root of 3y times x minus the square root of 3 and y, and FOIL it. But you're in pre-cal, you should be able to do this in your head. So that's going to be squared, and then you'll have 2 of these. Then when you square the square root of 3, that's going to be a 3. Okay, here I'm going to leave that square root of 3 on the outside and multiply that quantity together. So let's see, x, y would be positive. That's going to be negative 3, so I'm going to have a negative 2 x hat, y hat. I'm going to keep that 2 there, and again I'm going to FOIL that out. Pretty messy. Okay, so the next thing I'm going to do is I'm going to go ahead and distribute where I can, which would be this to all 3 of those, and this to all 3 of those. Okay, so as I distribute, square root of 3 times the square root of 3 is 3. Same thing here. Then distributing the 2. Now, before you start collecting any other like terms, look at everything that has an x hat and y hat multiplied together. These must add to 0, because if they don't, you've made a mistake and you just need to go find your mistake and sometimes just start over. So those, I have negative 2, and positive 4 of them. Those add to 0. That's a good thing. Now I'm going to collect like terms. All right, so I have x squared here, here, and here. So that's 1 and 3 is 4, so that's 10. Then I'm going to look at my y squared terms, and that is 3 minus 3 is 0 plus 2, so that's a positive 2. Looking better. I already know that that's an ellipse because both variables are squared and both coefficients are positive. Let's put that in standard form. So I'm going to divide by 40. Look at there. So let's go back and look at the graph from number 3. It was an ellipse. Remember, we had calculated that the angle of rotation was 60 degrees. So if this is your new x-axis, remember, to graph an ellipse, you would go out on that new x-axis plus or minus 2. That looks like 2 to me. And here the square root of 20 is a little bit more than 4. That looks pretty good. So that is your ellipse. This is in the new standard form without that xy term. Be patient, be neat, you can do it.